How can an aircraft fly at 33,000 feet and above when air pressure is lower? It is not a puzzle. Aircraft flight at high altitudes, such as 33,000 feet, can be explained by the principles of aerodynamics and the physics of flight. At 33,000 feet, commercial airplanes are cruising at a high altitude, where the air is thinner, lower air density, compared to sea level. However, airplanes are still able to generate lift and maintain flight due to several key principles. Number 1. Lift and Bernoulli's principle. Lift is generated by the wings of the aircraft, which are designed with a specific shape called an airfoil. The airfoil has a curved upper surface and a flatter bottom surface. However, is airfoil shape mandatory? The answer is a big no. It is, however, the most economical and optimal way. Even a flat-winged aircraft can fly. When air flows over the wing, the air moves faster over the top than beneath it. According to Bernoulli's principle, faster-moving air creates lower pressure, while slower-moving air results in higher pressure. The pressure difference between the top and bottom of the wing creates an upward force, or lift, that counteracts the weight of the plane. At high altitudes, even though the air is thinner, airplanes are still moving at high speeds, which allows them to generate enough lift. The wings are designed to be efficient in these conditions, and modern aircraft engines are powerful enough to provide the necessary thrust to maintain the desired speed. Number 2. Thrust and engine performance. Although the air is less dense at 33,000 feet, airplane engines, such as jet engines, are designed to operate effectively at high altitudes. Jet engines work by compressing the incoming air, mixing it with fuel, and then igniting the mixture. The engine generates thrust to propel the aircraft forward. Even though the air is thinner at high altitudes, the engines can still produce enough thrust to maintain cruising speed. Number 3. Altitude and pressure. At higher altitudes, the air pressure is lower, but airplanes are pressurized to ensure that passengers and the aircraft systems function properly. The cabin pressure is maintained at levels equivalent to an altitude of around 8,000 feet, ensuring comfort and safety. Number 4. Aerodynamic efficiency. At higher altitudes, the air resistance, drag, is lower due to the thinner air. This means that airplanes can cruise more efficiently, saving fuel. Although lift is still generated in thinner air, airplanes adjust their angle of attack, the angle at which the wing meets the airflow, to optimize lift and minimize drag. Number 5. Altitude and weather. Aircraft typically fly above most of the weather systems, such as clouds, storms, and turbulence, which are concentrated at lower altitudes. This contributes to a smoother and more efficient flight at cruising altitudes like 33,000 feet. While the concept of flight at high altitudes might seem puzzling due to lower air pressure, the combination of aerodynamic design, powerful engines, and the principles of lift and thrust make it entirely explainable. It's not a mystery, just a great application of physics and engineering. Thanks for watching. Please subscribe.